Vigorous, slow, no. Orange, yellow, bright, white, no, yellow, blue. Vigorous, slow, no. Bright, orange, bright, white, yellow, pale, yellow, ALCL, tree. No, yellow, no, now time for table 3. Fast with cold, slow with cold. Fast with hot, no. Disproportionation, dissolve the thin, less 9, 10. No 7, acid 2. Basic, amphoteric, all the rest are acidic. Hydrolyzed 7, 6.5 and 3. All the rest from HCl and sandy sulfur 3. Yeah. Why, hello there. You're probably wondering what on earth did I just say in the last 1 minute? Well, it's actually the Periodicity Song. Not really a song, more like a rap. Not really a rap either, it's a chant. Okay, whatever. Basically, the stuff that you need to know for A-levels lah. You can read the labels yourself, but I'll be just going through them as we speak. What? Okay, never mind. Vigorous, slow, no. That's the rate of reaction, how reactive the element is with dry oxygen. Orange, yellow, bright, white, no, yellow, blue. That's the color of the flame. Well, obviously when you react an element with dry oxygen, you get the elemental oxide. Yup, as if you didn't already know that. Now moving on, reacting the element with dry chloride and chlorine and heat. What? That's the second time. Okay, never mind. Reacting the element with dry chlorine and heat gives you the elemental chloride. Vigorous, slow, no. Bright orange, bright white, yellow, pale yellow, ALCL 3. No, yellow, no, time for table 3. The time table 3 is not actually part of the thing, but it makes a nice rhythm, so I'll just put it in. The pale yellow ALCL 3 is a pale yellow solid that is formed at the bottom of the test tube. It almost never comes out, but it's in the notes, so what the heck, right? Yeah, so one thing to note that chlorine doesn't react in both these reactions. It's useless. Useless, I say. Useless. Okay, next is reacting the element with water. Fast with cold, slow with cold. Fast with steam, no. Disproportionation. Okay, aluminum is fast with steam, but it's only for a short temporary moment because it forms a surface layer of oxide which renders it unreactive. Chlorine disproportionates into the Cl- and the Cl+, which is actually in group 7, so just remember that lah. I guess if it's hot water, then it would disproportionate to the Cl- and the Cl5+. Yes, that's right. Okay, moving on. Reaction of the oxide with water, and what's the pH of the solution form? Dissolve 13, less 9, 10. No 7, acid 2. Okay, quite simple, right? What else do you need to know? Okay, all the acids form. Phosphoric, sulfuric, hydrochloric. The pH is always 2, that's why it's acid 2. These two are unreactive. Yeah. Next, the acid-base property of the oxide. Basic, amphoteric. All the rest are acidic. This is my favorite. It's the shortest, it's the easiest. And the funny thing is, it actually comes out one of the most frequently. So obviously these two react with acids. This one reacts with both, and these four, the oxides, react with bases. That's right. Okay, the last column. Reaction of chlorides with water and the pH of the solution. This one actually comes out a lot, so emphasize, look at this. It's very important. Hydrolyzed 7, 6.5 and 3. All the rest from HCl and sandy sulfur 3. Okay, what does it mean by hydrolyzed 7? All these magnesium to chloride actually hydrolyze in water. Na just splits apart into Na plus and Cl minus. Don't ask me what that means, I'm just memorizing it. These two form the aqueous complex things, with the H2O6. Yeah, and then as you add more water, one of the H2Os in the complex becomes OH minus, and the H plus is transferred to a H2O ion to form H3O plus. Okay, so that's why there's a slightly acidic nature. Al does so more than Mg because of its higher charge density and thus stronger polarizing power. So it's able to, polarize the OH bond, blah blah blah, you get the drift. The rest form HCl, as in HCl is one of the products in the reaction, in the right hand side of the reaction. What do the other terms mean? Well, if you're lazy like me, or rather if you can't even work out the solution, the equation like me, then remember the products. For silicon, sand is formed, as in SiO2. Do note that sand is a white solid. It came out in our prelims. Don't be tricked. Sand is not a yellow solid, or at least for this case, it is a white solid. P doesn't form any additional product. Rather, it just jumps straight to forming phosphoric acid. S forms SO2 and sulfur 3. That means 3 moles of solid sulfur. That's why the rhyme goes, all the rest from HCl and sandy sulfur 3. Do note that the S chloride that is always tested, or rather most of the time tested, is H2 Don't ask me why, I don't know. Frankly, I don't care. The last part is obvious lah. Chlorine doesn't have a chloride, so there's nothing relevant to learn. Yeah, so just memorize this. I hope it does you wonders. I don't take any credit, but neither do I take any blame, so don't scold me if you messed up the order or whatever. It usually works. Bye and have fun.